Hi, this is from Shaoduo and Ruofeng, and this is our project 5, which is naval Minkowski morph. And currently we're only showing the morph between the solid 1 and the solid 2. And we will show you the whole animation later. Um, First, let me introduce some basic things, editing options for this project. So basically, you can change the view, zoom in and zoom out, and change the view towards the specific solids. Yeah, if you change the view a little bit, this will have nicer result. Okay, and we have the rotating. You can rotate the solid. Okay, and you can follow the morphing solid like this. Okay, so we also provide the ground shading of the 4 solids. And for the current solid that has the focus, you can edit the solid by its profile here. Okay. Yeah, and we can show only the green triangles, only the red triangles, the faces, and only the quads, and all of them like this. And you can insert the points to the profile to edit the solid. Yeah, so this is a non-convex solid, and delete it. Yeah, and you can also change the sampling count. Okay, and to make it convex if it is not a convex solid. See that? Non-convex, convex. Okay. Okay, so for the part 3, firstly, let me show you the Bezier interpolating, which interpolate between these 4 solids, and these 2 controlling solid is not the path of the morphing solid. And as you can see, there are some glitches in the morphing, but the phases morphing are totally correct. Yeah, and the quads morphing is a little bit has some problem. These are the total result. These are only the green faces, only the triangle faces. This is only the edge to edge morphing. Okay, then comes the navel interpolating, in which the morphing solid will pass through the 2 controlling points here, the solid 2 and solid 3. As you can see, there are some problems in the edge-to-edge quads. This is the result that only has the face-to-vertex morphing, and this is the result that only has the quads generated by edge-to-edge interpolating. And these are the total results. uh, we let the camera to follow the morphing solid.
So I'll explain how do we extend the face to vertex morphing and the edge to edge morphing. So, well, we know that for face to vertex matching, we have a face. Suppose we look at the two meshes cases. We have a face in the first vertex in the first mesh A, and we want to find a vertex in mesh B such that we can find a linear interpolation between the 3 points, the three vertex of the face to this this vertex. So in some time t, so the triangle will look like this. And for edge to edge matching, we have an edge in mesh A. We want to find an edge in mesh B, or maybe more than one edge in mesh B. Maybe this one. And then for these 4 points, we can connect every pair of them to have a quad, basically something like this. So in time t, there will be something like this. Okay, so this is the two mesh case. So how do we extend this idea to 4 meshes? So we have mesh A, mesh B, mesh C, and mesh D as shown in the screen. So how do we extend to that? Well, Bayesian and Neville, they are almost the same, just the formulas are different. So as long as we have these 4 control points, and then we plug in the parameter time t, we can calculate the location for that time. So okay, so for face to vertex matching, so for every face in mesh A, we want to find the matching vertex in mesh B, vertex in mesh C, and mesh D. So this is the same procedure as the two mesh case. So for this point, this 4 point will interpolate a curve, either Bayesian or Neville, doesn't matter that much, I think. So for this 4 points will interpolate a curve, also another curve. So for every face in mesh A will have the animation for that face. So that should be easy to understand. And this is not enough. We also want to find a meshing vertex in for every face in mesh B. So there will be a point somewhere in mesh A that match this, and also in mesh C there will be some vertex matching this face, and some vertex in mesh D will match this face. There will be also some 3 Bayesian curve or Neville curve that interpolate these 4 points. So also here. So in our code, we match each face in mesh B, each face in mesh B, each face in mesh C, and each face in mesh D. So that's the face to vertex matching. So that is what is shown in the screen. Only the green. Which one? Okay, only the green faces you see there. So okay, let's turn to edge-to-edge matching for 4 meshes. So we have 4 meshes, as I said before. Okay, so that's a little bit tough. For every edge in mesh A, we want to find an matching edge in mesh B, maybe more than one. I assume that, and another one. So okay, we have a quad here, as in the 2 meshes case. So we'll have some actually okay, so no, we don't connect these points. We have these 2 points here, and for this point, let's look at this point P, and we know that P will connect some points in mesh B and some points in the edge in mesh C and mesh D. So these 4 points will have a Neville curve or Bayesian curve. It looks like this, and this point will also goes to this point, so it will have another curve, I guess. It go past this point and that point, and so we go through every pair here. So in our results, sometimes it looks good, sometimes it's a little bit, I don't know how to say, a little bit like the dendrite splitting out. In our case, not always that an edge can find a match in all the 3 other meshes. So sometimes you just see those holes in the mesh. If you go a little bit inside, you can see the internal organs. But currently we don't find a good solution for that. So but it looks good from the outside sometimes, and the 2 mesh case is already perfect. So enjoy.